Welcome to Lyme Time. I'm Allie from the Tick Chicks. We are all more than Lyme disease and chronic illness, and together we stand with you to overcome and rise. I'll bring you closer to the experts in cutting-edge treatments and even a few unexpected ways of healing. I'll ask the questions you want answers to regarding Lyme disease and successful ways of getting you closer to 100%. We are in this together and will not be defined by Lyme. Well, today my guest is Dr. Jyotsna Shah, who is the CEO of IGENEX Lab. IGENEX is a lab testing center where all they do is test for tick-borne disease, and they have done so for over 30 years. IGENEX can create custom infectious disease testing using all the latest technologies, including PCR, Western blots, IGEX spot, immunoblots, FISH, and IFA. IGENEX is fully CLIA CMS certified, as well as being licensed to perform testing in all 50 states, including New York. And I did notice that they also added some COVID vaccination response testing and special events testing for COVID. But today we're going to focus on Lyme. And I'm going to tell you a little bit about the lab. As scientific research and knowledge of the causative organism of Lyme disease increased at a feverish pace in the late 1990s, it became clear to Dr. Shah that the commonly accepted testing criteria for Lyme disease were both too restrictive and incomplete. As she performed more research into Lyme disease testing, it became obvious that the CDC criteria were not adequate to serve the population that was being infected by Lyme. By working in close consultation with top scientists vested in Lyme research, physicians who are treating patients, hands-on development in the lab, and years of evidence and validation studies, Dr. Shah and her team have developed their own in-house testing criteria. By using a wider spectrum of both relevant proteins found throughout all the stages of infection and more strains of the organism that are found in a wider distribution in the world, more true positives have been found without sacrificing specificity. And here is a bit about what IGENEX says about itself. They say, as we have learned more about B. burgdorferi, other Borrelia, and the co-infecting organisms throughout the years that cause Lyme disease, we've continued to increase our menu of tests for tick-borne related diseases. We were the first group to identify Borrelia burgdorferi in ticks in California. We were also the first to identify Babesia microti in New York, Switzerland, and Australia using our exclusive patented FISH technology. Now we are the first to introduce relapsing fever Western blot testing. Relapsing fever mimics symptoms of Lyme disease. This issue has become a challenge for physicians finding suspected Lyme patients negative on standard tests. We now know that there are two groups of Borrelia known to cause disease in humans, including B. burgdorferi sensu-lato that causes Lyme disease, and then the relapsing fever Borrelia group that causes tick-borne relapsing fever. Through commitment and steadfastness, IGENEX is the only lab today that accurately differentiates between the two. At IGENEX, we excel in research and development. We spend an industry-leading excess of 15 to 20% of our net profits on research and development to continuously improve our diagnostic testing. We look for more and detect more without a corresponding loss in specificity, no matter when patients were exposed to the tick-borne pathogen. Dr. Shah, I am so happy to have you as my guest today. Welcome.
Thank you for inviting me to speak to your group. I'm really excited
honored.
as well.
We are honored. You're like a guest of honor to all of us that are in the Lyme community because, you know, we don't have direct access to the actual labs. All we can do really is go to our doctors and discuss with our doctors what the options are. And quite frankly, not all doctors know exactly what's available to them. And this is why I'm so excited to get some answers from you today. Well, we're first going to start with what led you to study tick-borne illness specifically.
It's a very interesting question. I I was working in Boston in a lab and developing tests, working in a lab that was developing tests for TB and chlamydia. As it happened so let me go back a little bit. When I first arrived in US, I was a fellow at Harvard School of Public Health. And one of the things that came up regularly, this is where I first learned of Borrelia, was the epidemiologist who is very well known, Andy Spillman, and his team had just started working on Borrelia. And they were looking at ticks in Nantucket and had set up a system to get the larvae, infect ticks, and have Borrelia growing. So that was my first exposure. This is something new, but didn't know much about it. So when I was working at a company which was involved in diagnostic testing, the person I used to share the lab with came from Willy Badofri's lab.
Wow.
Okay. So, and he came from Long Island, his family. So his whole family had been infected with Lyme disease. And he was the one who had looked at different Borrelia species and done a lot of work in Willy Badofri's lab. So I was exposed so much to it, continuous discussions going on. So we both felt that this was something that might become the future. Two things that were coming up. One was genetics at the time, and the other new field in infectious disease was Lyme disease.
Wow.
So
Wow. And
then
then not to
that,
date you, but can you tell us what year that was or what?
let me think, 1995, 96.
Okay.
1995. And so that was when it was really new. They were just coming up with what should be the diagnostic criteria. Everybody was working together at the time. There were no two groups or anything. So I said, let me think, which way should I go? And my other dream was to come to California. We always wanted to, but uh, we landed up at Harvard, and I spent 2.5 years there, and I said later on maybe we can move on to California. So I was always interested in coming to California, and I looked at two major projects, as I said, whether to go into genetics or into infectious disease. Lyme disease seemed very interesting. When the opportunity came, I decided I'll try it out and see what it is like. So this is how I joined IGENEX to run their research lab. And
Wow.
this was in 1997.
Okay.
And then one of the things, it was very new. I didn't know much about Lyme disease or anything else. My interest was fish technology, one of the things. And I had knew that anything that was bloodborne, uh, we could probably use that technology to identify new infections.
Hmm.
So that was one of the projects I picked up on Babesia to work on that. And there wasn't much known at the time. And we said, okay, there's something very interesting. It's transmitted by the ticks. And we were working with Dr. Richard Horowitz.
Mm-hmm. Of
And
course.
he said there was something like that there. He didn't know. And we started running fish, of course, not knowing what we were going to find. And we started finding Babesia in blood. So he started treating patients. They started becoming better. And he informed the New York State that there was Babesia in New York, which was like nobody believed that beyond Long Island there was no Lyme disease, there was no babesiosis or anything like that. So that's how we were the ones who said Babesia exists there. And then of course in California they talked about Babesia duncani, so we were looking at that as well, and the fish test would detect both. So that was one of the first things we did, and then moved on to uh, Western blots were already being done in the clinical lab. And then slowly, once I moved into the clinical lab, I got more involved with the clinical lab. I realized what the gaps are and what we were doing, had a better understanding of what was going on. And I realized that patients were having a disease, and because of the criteria set, a lot of patients were being missed. There were examples we would see that people seriously had serious disease, but they couldn't get treatment
Mm.
because they were not two-tier positives, CDC two-tier positive.
Yes, I still hear a lot about that, even
Yes,
today.
it
A
is
lot of
still
people
true.
say, I know I have it, but I do not have all the bands required. Mm.
Yes,
Yeah,
yes,
but I mean, we've come so far
yes,
since
we have.
1995, and surely since the 70s when all of this started coming out. You know, I mean, it just sort of started seeping out, and now it's on everybody's mind. While we're talking about the different types of tests,
Mhm.
I was with a neurologist not too long ago, and he said, well, the only test I'm going to do that I ever do is the ELISA test. And I wondered, does that have another name, or is that outdated now? I noticed you don't mention it.
No, we don't generally use ELISA in our lab because we don't think the sensitivity and specificity of ELISA test is around 70 to 75%.
Okay.
Okay, so now they talk about two ELISAs, giving you that you can do two ELISAs, and if both of them are positive, you are considered exposed. Okay, now that is what they've come out with. But the problem that if you do your math, you realize right away that if the sensitivity of one test is 70, the other one is 70, what do you end up with? About 50% sensitivity. So you're
Hmm.
still missing 50% of the infections. What has happened is that the two-tier testing, where they used to do the Western blot, has been replaced by some labs by doing two ELISAs. But it doesn't really answer the question or help our Lyme patients
No, it
because
does not.
yeah, that is the problem. Okay, so what we did was we always go out of the box, as you all know. We've been following the literature. I think it's so important to follow what is found. What we knew in 75 and what we know now is very different. We know a lot more. 25 years, CDC has not changed, really speaking. They're still in 95 guidelines, whereas so many new things have happened. There's so much more information out there, but they refuse to listen. For example, they still believe that there's one major species that causes disease B31 in US. That's not true. There are multiple species reported in the literature. It's not just us making or saying something, it's out there.
Sure.
And we need is a test that's going to detect all the species. And I think that's very, very important. And that is what we have tried to do. With the Western blots, there was no way we could develop a test that would pick all the species. First of all, it's very messy for us to develop a test like that. Again, Western blots, you're separating antigens by size. So there could be multiple proteins at the same position. So your specificity is not that great. So we developed the immunoblots.
Mm-hmm.
And the advantages of the immunoblot is that we can add species. If there's a new species, it's fairly easy for us to add within 6 months, once we have all the information.
Mm-hmm.
So on one blot, one test can detect all the major species that we know of, Borrelia burgdorferi, that causes Lyme disease. Not only that, one of the other factor that we all need to remember is that we don't live in an area, you mix with people, you travel, you go international, do international traveling, and we all know that diseases are present, or the ticks that transmit the disease are everywhere. So you could pick up a disease from anywhere.
Sure.
And it's not going to be local disease. So when you want a test done, you want a test that is going to pick up the infection is related to your symptoms and say, okay, this system can definitely rule this out, or it's definitely this.
Yes. Yes. Fascinating. And do you feel confident? How long do you think that is on the horizon to get one test?
Oh, we have it.
You
We
have it.
have our immunoblots will pick up European, Australian,
Wow.
and US, Mexican, South American strains. We know that. We already proved that.
Wow.
Okay,
That's
very, very clearly. I mean, that's data is there.
okay. So let's talk about tick-borne
Yeah.
illness. What
Mhm.
tests do you perform there for tick-borne illness?
Okay, I think this is something that would be very useful for all the listeners, is that the symptom, it used to be thought that tick-borne relapsing fever causes relapses, and that's it, that's the only symptom. But just like Lyme, we have the active phase, and then we have the chronic phase. I think the same pattern follows in tick-borne relapsing fever. The
Okay.
suspect, and this is with the help of all the physicians around here who would, they'll send their testing, and when the test was negative for Lyme disease, they would say, my patient definitely has Lyme. Why is your test negative? And my answer is, this is the best I can do at the time. And that made me to think, what is going on? Is there something we are missing? We're definitely missing something.
Mm.
Was very clear. So we looked at what is around us in California, for example. Tick-borne relapsing fever is here. So we said, maybe we need to start thinking about tick-borne relapsing fever, because the physicians here are saying they have Lyme disease symptoms, but they are not turning out to be positive. And it's not just one physician, it's multiple physicians. Many physicians have told me that. So we started looking, and so if something was, when the doctor said the patient has the symptoms, we started keeping those samples aside. And when we said, let's do some Western blots using tick-borne relapsing fever, Borrelia, because we make our own blots, it was possible for us once we get the culture. So we started doing that. And we found out that the patients where the doctors were saying that they had the symptoms started turning out to be negative on Lyme, but positive on tick-borne relapsing fever blots. So that was the beginning of our studies on tick-borne relapsing fever. And then the physicians, we would tell them, and they would say, my patient is definitely getting better.
Oh,
And they started feeding us, patient samples that we could just test for research. And that's how we were able to develop the test, working with the local physicians or physicians all over US to start out with. And that led us, by that time, we already had our immunoblots for Lyme underway. We said, what we need is a similar test for tick-borne relapsing fever, because it's the same story for any disease now. We have to think globally. We cannot think of it as an isolated disease in one part of US, for example.
that's
That's
right.
not the case. So our thinking has changed completely. Whenever we are developing tests, we always think of, well, the test has to work anywhere and everywhere.
Well,
So
and
our,
I'm a prime example of that. I mean, I am an extensive traveler, and
uh-huh.
initially I had gone to the East Coast and spent some time there and felt like I was probably exposed in the outdoors. I mean, it made sense with the initial Lyme disease. But recently I was bit by another tick, and in a completely different part of the country, came back to California, and that's where the tick relapsing fever showed up. Now it was just traces of that, but it was great because I knew, hey, let's go ahead and start treating for that. I could take action by knowing exactly what was going on in my blood. So I'm going to name a few of the diseases and tests
Yes,
that you
please.
perform. The Babesia, Bartonella, Borrelia, the Borrelia relapsing fever, er,
Ehrlichia,
Ehrlichia, and Anaplasma
correct.
rickettsia. And then you have on here pneumonia and chronic fatigue.
Yes.
Okay. So would you be able to test, for instance, any of these in terms of a chronic or long-term, could you give somebody an answer if they had it chronically?
We won't be able to say whether it's in Lyme. We have a fairly good feel when it's late stage, but with the other diseases, it's not that easy, because they might have IgM lingering on. There's not that much information. We can't differentiate, but we can identify it. Like, I'll give you an example for Babesia, because what happens in Babesia is, a lot of times, patients who might have had it for a long time. I just heard about this last week. There was a babesiosis conference, and Dr. Krause, who is very well known for babesiosis at Yale, also said that there is chronic babesiosis. Now, this is something we really had not heard so far,
Wow.
except from the physicians we work with, who said that they did find Babesia lingering in, and the only test they would get positive was Babesia fish at that time. None of the other tests were positive. But last week he said that's quite common. Babesia it can be chronic. So I thought this would be an important piece of information
Oh,
for
yes.
everybody. And so my recommendation really at this point is that we should be looking at it at two ways. One, you look for the pathogen itself, and the other way is to look for the response. And in case of Babesia, the fish test works better than PCR.
Okay.
So that's why we always recommend fish rather than PCR. And there are reasons for it, because our test is designed in such a way that it detects all the species of Babesia that we know of. And we published those papers last year showing that.
About how many species of Babesia?
Oh, okay. So there are 3 very common species of Babesia that cause human disease. One is Babesia microti, which is very common. Babesia duncani is important for us where we live in California. And then it's Babesia divergens, which is very common in Europe, is one of them. And we have found cases here, which is here known as MO1. And recently we have been, we couldn't prove that we can detect MO1 because it's something that wasn't growing. But recently Yale has been able to grow that.
Wow.
Yale University, and they sent us some cultures, blinded cultures, and we were able to identify all 3, microti, duncani, and divergence, using our fish test at the genus level and speciate it as well. So we know that we detect that, and we knew we were detecting divergence. So that test is very good. It detects all the Babesia species from anywhere else, everywhere. As far as IFA goes, currently we have 2 tests that we do. One, which is for microti, and the one for duncani. We don't have one for divergence at this point in time because that's not a common disease in US. But the fish test, we have made it because there could be variants that we don't know. And we don't even know whether the cultures exist, but a fish test would detect it.
Okay. And what I like about your lab is you're available to everyone. Because even if someone's doctor doesn't use IGENEX, you can order a collection kit online and get it and take it to your doctor. Yes. And then you can sit down with your doctor and you can go over what exactly you think that you should be testing for. Again, you really have to have a doctor that is educated in Lyme and in Lyme disease and tick-borne diseases. But then you do the blood draw there with your doctor, and then the results are sent to your doctor. So you can both go over them together, which is something I really like, especially for people that don't have a Lyme literate doctor. They can, in a way, help educate their own doctor, because when it comes back positive and so many different strains are appearing, it's really eye-opening for a lot of people. And it actually, it shouldn't be that way, but it is that way right now. On your website, you offer some free webinars, and you also have some great pages. The ones that I like are the TikTok page and Symptom Checker. And you have other pages there. Can you tell us about, which ones people respond to the most, what they can find out there on those pages?
I think the one Symptom Checker is a very good one. Our customer service guides them to that, and they find it very useful to kind of get a feel for what they might have.
Yes.
Now, the other resource that you probably are not aware of is that if your family doctor, you're using your family doctor to order the test, and when the test results come to them, we are here to help them understand, to interpret the results for them if they need help.
So
this
nice.
is something we provide to every physician. It doesn't have to be a Lyme literate physician. It can be a family doctor, and then we can guide you. We have a clinical consultant who can help out at that stage if there's some help needed by the physician, your family doctor, because sometimes you can't travel or do, it might be easy for your family doctor to work with the specialist.
Yes, so as long as they're open to doing these tests, sometimes the hurdle is to explain to them that it is real and it exists and you're not crazy And, you know, and of course, we're talking about after you perform other tests that
Yes.
and rule out other things. So some questions from my followers are, I have a few of them. The first one is there a specific test for, oh, well, we covered that. Is there a specific test for chronic or post-treatment Lyme disease?
Yes.
And basically, you're saying we will, I mean, it's a difficult question to answer, but actually one that probably somebody could self-diagnose in a way, correct? I mean,
Yes, but so the test I would recommend, this is what we have been recommending for any disease, okay? If you do not know at what stage of disease you are in, we recommend PCR and immunoblot together for Lyme disease. And if both tests come back negative and you still feel you might have the symptoms, then it's the IgE export test.
great. Well, I love that answer.
mean,
That's amazing. Another question that we have here is, do you test the actual tick? If somebody pulls a tick off their body, can they mail it to you?
yes, they can. We test for all the diseases.
And then, so they can just put it in a little Ziploc bag, and then it doesn't even have to be alive still, right?
No.
And it doesn't matter how old it is?
No, it really doesn't.
Okay.
DNA is pretty stable.
I think that was so helpful for me when I got the second bite, because I couldn't believe, I couldn't actually believe that such a little tiny nymph tick could have created such a problem. I mean, it scarred my foot. It was on for less than 10 minutes. It was super aggressive. And it helped me in knowing it was actually a Lone Star tick, but it helped me in knowing, because guess what? And I don't know if I'm just sensitive to it now, but I had symptoms start within 48 hours.
Wow.
24 to 48 hours. And I was very nauseous. And at first I thought possibly I maybe had COVID, because that's what it felt like. And then no, come to find out it was my little friend.
I have one suggestion for everybody here.
Yeah.
If you get a tick and you're going to send it to us, take a picture, because, you know, so that then it will help us as well. If we find something new, we can tell you, and I think you educate everybody around you.
That's great.
So, I would love that if people start sending us pictures of that. It can be digital. It doesn't have to be, you know, but with the tick, if we can if you have the picture, you can send it to us, or we can somehow get it. But that would be my request, because we have tried to take pictures when they come here. By that time, the pictures are not great. You can't really see much.
Yes, I took lots of pictures of mine, because mine was so small that I had to enlarge it on my phone to see the markings on the tick. So it's always a good idea. And also, you know, I've posted a lot about it too afterwards, and it's nice to know exactly what you have. Why do some infections present symptoms and are clinically diagnosed, but why do they not show up on tests?
Good question. Why don't they show up on the test?
No, why do they not show up? So in other words,
okay, there are reasons for it. Either it's gone into hiding, so you can't see it. Secondly, patients' immune response could be quite different. So we may not detect some of the markers we are looking for. I mean, those are the most common ones that I can think of, or the levels are beyond our detection limits.
Isn't the life cycle, doesn't it sort of keep, I've always heard that it has a cycle. And so it'll cycle every few weeks or months or something, and it'll cycle. And that if you don't catch it at the right time in the cycle, it could also read as a negative. What do you think about that?
So basically different diseases have different way. Like the most difficult one is Lyme, because it goes into hiding. Once it goes into hiding, this is just our own thinking, is that, you know, it's releasing something slowly into the bloodstream. And therefore you get this low level of specific response to IgM only. It doesn't convert to G in a lot of patients. So even a late stage disease, if you send your sample to the normal labs, they may not detect it because they're not looking for all the markers.
Hmm.
We have found that in chronic stage, in Lyme, I mean, it's fairly, we've seen it in a lot of patients, is that they will sometimes be PCR positive at that time. Maybe it's dependent on when you collect the sample, and they'll also have some markers which give us an idea that this is really late stage. And I mean, literally, this happened several years back. We got several samples from Oregon
Hmm.
because they heard that their symptoms are probably Lyme-like. These were not young, not they're fairly older people who had never been treated, and we got samples coming from them, and we knew right away that this wasn't a new infection, but
Interesting.
they were PCR positive. So then I called the doctor up and I said, I'm seeing something very interesting in this group of people. They all have late stage markers. Some of them are PCR positive. So I'm assuming they may not have been treated. I don't know. And he said, you know what? They heard about it. These are not new infections. They've had these symptoms for a long time, and we didn't know what they were due to. And once the word went around, all the patients wanted to be tested, and that's how we found them. But that's how we know these were late stage markers. And the doctor said, how did you know this was not? I said, I'm just asking you because this is an observation we've been making, and
Mm.
we just wanted to know.
Interesting.
So
Interesting. And could somebody test positive and never ever exhibit symptoms?
yes, yes, that is true. If I were to look at we just did a study where we had 100 patients supposed to be controls, no symptoms. Out of that, three were positive. So three, that rate I have heard can be anywhere from 3 to 10%, depending on the endemic region. People will have antibodies very strong. I mean, two-tier, very strong antibodies. If you looked at it, you would think this person's sick, but they don't have any symptoms. So you do get people in endemic areas. There will be a few, and it's a well-known documented phenomenon that you could be PCR positive as well and have no symptoms.
That's incredible. Yes, I even had somebody say that their baby had tested positive,
Oh, that happens.
but they were not exhibiting symptoms. So I guess, in that case, she was wondering, do I treat it or just leave it since there's no symptoms?
Oh, I'm going to tell you a little bit more on that. I just heard this week. This has been a week of Lyme. And there are so many conferences. So there was one on pregnancy and Lyme.
Yes.
And one of the things that was brought up was that the mother was asymptomatic, and the child, it was transmitted. That's
Mm.
what they think. And the child at 4 years ended up having rashes and things like that. And they
Okay.
claim that it wasn't something new. They believe, this is what I heard, that they believe that it was transmitted from the mother. And we know that happens because if a mother is positive or has antibodies, there are physicians who are quite aware of this now. So they will treat the mother, but also the recommendation is to test cord blood uh, at the time of birth to see if it's positive or negative. And we have found Babesia and Lyme in patient in cord blood.
Interesting.
Yep.
That's
Bec-
very, very interesting. That's very scary to a lot of people because they know they have Lyme going into pregnancy. They're not sure. I mean, obviously, they've been working on it for years to clear it. Perhaps it hasn't been cleared. What are the percentages of that being passed along? And that's a
yes.
very real thing. And I often think of Lyme disease, even though it's bacteria, but it acts like a virus. In my opinion, it acts like a virus. It migrates, it burrows, it is chronic. Sometimes it possibly is passed along through birth. And so anyway, that's just my little observation.
No, it's true. It is because on Babesia, there's so much information on that. And Lyme,
Yeah.
too. Now it's accepted that these diseases can be transmitted.
So when people do a lot of testing, let's say,
Mhm.
and they've been treating themselves, and let's say they get to the stage that they feel really, really good, and they go back and they test and the Lyme still is present, or a tick-borne illness is still present. Does it ever go away in your
I
blood
have,
work?
yes, we do see it clearing out. I just looked at some data recently. These were samples collected, and there were two samples. In some cases, they were positive the first round. Second round, they had no antibodies or anything that cleared it. I think it's a matter of when this test was done and what kind of treatment they got.
Okay.
And I've heard from other physicians as well, it does clear out if the treatment, it might take longer, but it does clear it out. Maybe not in all patients, but in most, it can clear out. With other co-infections, for example, we can see it as well. I mean, if you have IgG antibodies at low levels, it really means that you clear the disease you were infected, and that some people will have low levels lingering on, and that doesn't mean that you have the disease.
Sure.
You cleared it.
So you can still have it in your blood work, but feel symptom free.
Yes, and that is when you want to know that the importance of titers. I mean, it's reported as a number, and beyond which number it's active based on what we know right now.
Mm-hmm.
So that's why it's important to have a discussion with the physician sometimes. And if the physician needs some help, they can always call us.
Yeah, I have noticed that whenever I have a question about any of my blood work, I call you, and it's very friendly there, and
Yeah.
well, I've always been able to get help. And so, would you recommend the average person gets tested? I mean, once they are tested, how often should they continue to be tested? Is that just a personal preference?
I think, yeah, it is. But once you are tested, you know what you have. And then if you really want to see if you're cleared it, maybe 6 months down the road, you might want to test, because it takes a while for all those, symptoms to disappear, for you to feel better and see, are you making any progress? In some cases, you'll see it. In some cases, you're not going to see it.
Mm-hmm. Yeah. I mean, it can be kind of maddening when you're really relying so much as a patient on numbers, because we don't know what the numbers mean necessarily the way you know what they mean. And sometimes we can become very, very obsessive about the numbers because we're just trying to kill this bacteria. So it's a kind of I think it is a personal decision whether you want to keep going back
Right.
into it. I kind of think just go off your symptoms. And what I do is I test. It's so expensive. So I mean, I can only test about once every 2 or 3 years, and I find that works for me, mostly just to make sure I haven't gotten anything in the meantime.
Mhm.
And what are the well, what affordable options are there for testing?
Okay, this is $1 million question you are asking me, because
Literally $1 million.
yes, because the problem is that testing is expensive, um, and we are not in the system. We've been trying. It's not easy to get in. The big labs are controlling it. Unfortunately, that's the way the insurance works. We are trying to look for ways how we can help. So this is why the panel that we offer is expensive, and we don't recommend, as you say, keep on testing it. You get an answer once and for all, rather than going around spending thousands of dollars. It appears expensive, but we try to give you the best panel. We'll advise you and say, do this panel. It looks expensive. Ask them if they can't afford it, which would be the one they can go for, and then add on. That's the unfortunate part, because the insurance doesn't cover it.
Yeah.
But one of the things that we are doing is we file for insurance for patients.
Oh, really?
Okay? Yes, we do.
Oh, nice.
So, and again, everybody's insurance is different. So that is the service we provide afterwards. And whatever money comes back, whatever the insurance pays, goes straight to the patient. We
That's
don't
so
keep a
nice.
penny of that. We just provide the service. A lot of times the check will go directly to the patient. If it comes to us, we just send it to the patient right away.
Now,
So
so
that is our help that we provide because we can't do anything better. We are looking at ways. I mean, I brought this up with HHS the other day. I said one of the problems that we are having is that our testing is expensive, but in order to reach the rest of the population, we need this test to be FDA approved so that more labs can do it. And for that, it's very expensive. We need some help to be able to do that. And then hopefully we can reach more people, or the other way is somehow work a system out whereby, the insurance can be used more than just out of network. Because right now, some patients get like 80%. We have seen reimbursement rates depending on their, some will get 20, some get nothing. So there's a big range, but at least that's something we felt that we could help patients with.
yes,
We started a couple of years back, and you just have to say you put in your information, say you want to file for the insurance claim, but we still ask you to prepare upfront because we don't know what's going to happen, who is going to get it. But quite a few people have got it, depending on your insurance.
and so what are we talking about out of pocket initially, whether insurance covers it or doesn't cover it?
I think
I'm sure
2,500 is the test that, the panel that we like most, panel 6, TBD6 is our most favorite one. And most of the doctors who have been using it like it because it gives you, it's a comprehensive panel, looks at everything.
And how much is that? I'm sorry.
2,600 roughly.
2,600. And is there,
remember exactly, yeah.
and then up to the insurance if they will cover it.
Mhm.
And then let me ask you this. Let's just say somebody wanted something very basic. Is there ever just a
Yes.
basic test?
Yes. So when you want basic, you're really starting out with Lyme.
Yes.
I would absolutely say go for the immunoblots, if nothing else. That's going to cost you $450 if you just did that. Lyme.
Is how much? I'm sorry.
$450.
450. Okay.
Yeah. Okay.
I think that's better. That's getting, at least that would give somebody a head start and in knowing what they're dealing with. And how accurate are those tests?
Very accurate. If I were to tell you, we just did a CDC panel recently of 290 samples. We were able to get a sensitivity of 90%, specificity for G 100%, M 98.4%. You can't get anything better. Okay,
you should be very proud about that.
Not even published data. I'm just giving you, and this is where we were.
That's exciting. That's so exciting. I mean, very fun facts about, at least something fun about testing, because we seem to be talking a lot about testing these days and with the pandemic, and we all now are aware of what percentages are acceptable, and you're even better than all of that. And if they do get a negative, if somebody did this basic test and they got a negative, do you think they should test again if their symptoms persist?
Let's see. So depending, I mean, sometimes you don't know where they were in the disease, right? So the other part we asked them to add is PCR. Combining those two tests is about 600 something. Just a second. Give me a second. I'm just going to go in and pull something out.
Okay.
So for Lyme disease, we have a panel that does PCR and immunoblots together.
Okay.
Okay. And that panel, in fact, is $686.
Okay.
That should give you an answer. You're looking at the active disease, late stage, early stage, you're pretty much covering it.
Really?
Yes,
that would be the test.
That's just Lyme disease. I'm going to give you some other clues as well, okay?
Okay.
Lyme-like symptoms are caused by two Borrelia groups, tickborne relapsing fever and the Borrelia group. And so what I've done, this is really something that makes a lot of sense. For under $1,000, you get both these panels. Okay, I'm talking about PCR for Lyme, TBRF, all 9 species of Borrelia burgdorferi, 8 species of tick-borne relapsing fever, all this, you're looking at almost 17, 18 different Borrelias that can cause Lyme-like symptoms. You get the full panel.
Wow.
It's under $1,000.
And that test is how accurate? That
very accurate, the most accurate you're going to get.
right. So then in that instance, if somebody ordered that at the $1,000 level and it came back negative, they would not need to test again.
Not for Lyme and TBRF, but remember the co-infections. What we are finding that co-infections can happen by themselves as well.
Right.
You can get a Babesia infection. You can be very tired. One of the symptoms, night sweats. So, and some of them overlap, like TBRF. Sure. So that is why there are a couple of other things we have come up with is a TBD4 panel, which looks at antibody response only to all these infections, tick-borne infections. That is just under $1,600.
Right.
Now, what you are getting is the immunoblots for Lyme, tick-borne relapsing fever. You are getting Bartonella western blots, which is very important because you're looking at all 4 species. Then you're also getting Babesia microti, Duncani, Anoplasma, Ehrlichia, Rickettsia. So that's a very, very full panel if you just wanted to look at the antibody response. And most people who have the disease would have some kind of response, okay?
Okay.
And then there are people who don't make antibodies. Those are the ones who would be missed. And that's about 20%. If you don't know where you fall in, we have another panel, which I was talking about, TBD6, which is 2,621. That includes the fish, PCRs, and immunoassays, all of them.
Are you saying that some people do not form antibodies?
Yes, that's true.
This is so complicated. And I feel for you, and I feel for people trying to answer these questions, because all anybody wants to know is why can't we get proper testing, but there's so many layers to this.
It is.
It's very difficult, and but we've had so much progress made here. I have to ask you this just out of curiosity, since you've worked on it for so long and you know all these diseases in the lab. Is there any truth to it to have ever been developed in a lab for bioweaponry or anything like that? Have you ever thought about that?
You hear things.
Yeah.
That's all I'll say. But I don't. I won't say anything. I can't comment on it.
Got it. That's just always something that people think about, for sure. And I guess that's about it. I have, is there anything that you would like to say to everybody out there? Maybe what's on the horizon for you guys? What we have to look forward to, or just any advice that you might offer up to our listeners?
One of the things that we are working on and will continue working on is that we want our tests to detect the infection irrespective of where it comes from. We've successfully developed tests for tick-borne relapsing fever and for Lyme. Our Bartonella panel will be coming out soon because there are 13 species of Bartonella that cause disease that we know of today. And so we want them, some of them are minor variants, but we want to make sure that we have a test that will detect them. So we are working on that. Hopefully next month it should be out, ready for use. And basically what we are going to do is replace the Western blots with that. So there's no increase in price or anything. We just feel that it's a better test, so we can give more information. And we are trying to do the same thing for Babesia. Now that we know more, there's so much more information out there now for Babesia. So we hope that we can make use of it and work with the right groups to get a test that helps. So the goal here is to keep on improving so that we can provide better testing to our patients. And we are, of course, working on ways how we can get insurance to be accepted, or what are the ways. We're always thinking about it, trying to work with HHS and everybody else. Who knows if we're going to be successful, but we are trying. I want everybody to know that we understand that these tests are expensive. We try to cut it down to as much as we can, by providing panels, and our panels are based on what we are finding in patients and what we find in the ticks as well. That's very important,
Mm.
because there's no point in developing something that doesn't make sense just because you want to add in. I mean, we haven't added any viruses to the panel as yet. I am not that convinced that those are the most important ones at this point in time. We're looking into it. That's all I can say. Mhm. So just a word about the COVID. I thought that would be just
Sure,
for,
yes,
so
absolutely.
basically one of the things that people keep on asking for COVID, and also because Lyme and COVID, the same, fatigue, and there a lot of Lyme patients are wondering how they are responding once they get the vaccine. Is it going to work? So what we have done is we've developed a panel to look at it. And we did a study on about 30 people who were vaccinated from before and after vaccination for 7-8 weeks, to see when do people start making antibodies, because that is what protection is all about, having antibodies.
And
And we are finding that if anybody wants to test themselves, I would say test after 6 weeks,
6 weeks.
because by that time you should have made antibodies, good antibodies, and we would be able to detect them. And we are able to detect, which is very interesting, is that, the vaccine molecules,
Yes,
antibodies to that. And if it's an infection, it will be different.
very
We have a,
interesting.
we have a marker that would not be positive if it was just vaccine.
Wow. And any difference in what type of vaccine anybody should look
So
for if they
far,
have
we
Lyme?
haven't seen any any differences in antibody product, because all of them are to the spike protein.
Right.
All the vaccines are to the same target. That's what
Okay.
we have very little data on J&J, but Moderna, Pfizer, very similar.
Maybe I'll come up there. It's been about 6 weeks since I had the J&J.
Sure.
Well, thank you again for your time. Just lots of love your way. We'll be in touch, and thank
Yes.
you again.
Goodbye.
Bye-bye.